This is your standard periodic table. There's about 100 or 30 or so elements in the periodic table. The way this is devised is sort of like a phone book. So you can always consult this, never memorize it, and always bring it to you for any type of examination. So the first thing I'd like to show you when you look at the periodic table is how this is arranged. So we have columns that go from up to down, and we don't call them columns, but we call them groups. Now, there's different versions of the periodic table. This periodic table version calls this group 1A, and then you have group 2A, and then you skip to go to group 3A, 4A, 5A, 6A, 7A, and 8A. That's one version of the periodic table. Now, another version of this table doesn't have the A-B designation. Another version of this would just simply call this group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, and group 9, group 10, group 11, group 12, group 13, group 14, all the way to group 16. The second aspect of the periodic table is looking from left to right, going this way. That's called a period. So we can have group 1, and then we would have a period that goes from left to right. It sort of runs horizontal. This would be period 1. This would be period 2, going left to right. This would be period 3, 4, 5, 6, and 7. So up and down the columns is called a group. Left and right, horizontally, is called a period. There is a couple of groups that are important. One is group 1A, or group 1, but we'll just go with this designation, group 1A. And these are called the alkaline metals. Group 2A, when I say group 2A, I'm talking about beryllium, magnesium, calcium, strontium, barium, and radium. Those are called the alkaline earth metals. Alkaline metals, group 1A, are going to have charges of +1. Now here I'm talking about ions, a charged particle. The alkaline earth metals, group 2A, are going to have a +2 charge. Again, I'm talking about ions. Now what is an ion? An ion is just simply a charged particle. Now that charged particle can be a plus charge, +1, +2, +3, +4, +5. And if it has a positive charge on that element, it's called a cation. And an charged particle can have a negative charge, -1, -2, -3. Call that an anion. Negative anion is negative. So there's two types of ions, a cation and an anion. Here we're talking about the gain or loss of electrons. Okay, that's going to be very important. All right. So what we see here in the periodic table has nothing to do with ions, because you don't see a charge here associated with any of the elements. Okay? But I told you that the alkaline metals, if they're going to form an ion, they'd like to form a +1 ion, so they'd like to be a cation. So lithium, let's just take lithium for an example here. Lithium by itself is neutral as you see it in the periodic table. Let's say lithium wants to form an ion. Let's say lithium wants to get charged. So the loss of one electron makes lithium +1. So the ionic form of lithium is Li plus, or lithium +1. The ionic form of sodium is going to be Na +1. I put the plus sign as a superscript. Potassium, neutral by itself, is K. What is potassium as an ion? Well, potassium is in group 1A. It's an alkaline metal. And group 1A likes to have a charge of +1. And if it has a charge of +1 as an ion, an ionic form, potassium would be K+. All right. It's important that you say the word ion. If I'm talking to you and I say cesium, that's one thing. But if I talk to you and say cesium ion, that's a whole different thing. That is cesium that has lost an electron. Okay? So if you lose an electron, an electron being a negatively charged subatomic particle, if you lose one electron, you become plus. What happens if you lose 2 electrons? If you lose 2 electrons, if you give off 2 electrons, 2 minus charges, you become +2. So let's say I have 2 electrons, 2 minus signs, and then I give them off. And if I give them off to you, you become -2 in charge, and I become +2 in charge. So when you give off an electron, you become positively charged. When you gain an electron, you become negatively charged. So the alkaline earth metals, their ionic form like to be +2. So that would be beryllium itself is beryllium, but if it wants to form an ion, it's going to be beryllium +2. Magnesium as an ion would like to be magnesium +2. Calcium as an ion would like to be calcium +2. Strontium as an ion would like to be strontium +2. Barium as an ion would like to be barium +2. And I cannot emphasize enough that barium is different than barium +2. Barium, as you see here, does not have a loss or gain of electrons. Barium +2 has lost 2 electrons. By virtue of losing those 2 electrons, it has become barium +2, the ionic form. So if you gain an electron, you gain a negative charge, you become minus. Group 6A. This does not have a specific title like alkaline metals or alkaline earth metals. But what's important about group 6A elements, we're talking about oxygen, sulfur, selenium, tellurium, polonium. But most of these are going to be -2 when they become ions. A -2 as ions. Or a -2 charge. What does that mean? It means that elements in group 6A like to gain 2 electrons. And when they gain 2 electrons, they become a -2. So oxygen by itself, neutral oxygen, is going to be O, but oxygen as an ion is going to be -2. Sulfur as an ion be -2. Selenium can be -2. We have seen selenium also have negative charges besides -2. So these tend to have a -2 charge when they gain electrons. Group 7A, this has a specific name. These are called the halogens. I've heard of halogen lamps. Halogens consist of fluorine, chlorine, bromine, iodine, and acetylene. We're really not going to concern ourselves with acetylene the more downstream or further down the group. But all of these have unequivocally a -1 charge as ions. So group 6A and group 7A would like to be anions. They would like to gain electrons. So fluorine would be F-1. Chlorine as an ion would be Cl-1. Bromine as an ion would be Br-1. Iodine as an ion would be I-1. It would be anionic. Finally, group 8A. These are called the noble gases or the inert gases. Helium, neon, argon, krypton, xenon. These are noble or inert gases. And these noble or inert gases have no charge, so they cannot form ions. When I say they cannot form ions, what does that mean? It means that they cannot give or take electrons, so hence the term inert. These tend to be non-reactive because their electron shells are completely filled with electrons, and they're content, hence they're noble. 1 and group 2, or group 1A and group 2A, are going to form +1 and +2 ions respectively. Know that group 6A and group 7A, equivalent being group 16 and group 17, like to form -2 ions and -1 ions respectively. And group 8A or group 18, in another type of classification system, are all noble and are unreactive, hence inert. Can actually draw a line here, and I'm going to label these elements boron, silicon, arsenic, delirium, and also germanium. These are elements that are touching that staircase. Antimony, these 1, 2, 3, 4, 5, 6, 7 along this staircase are called metalloids. They're going to have properties of both metals and nonmetals. Anything to the right of this are your nonmetals. That would be your carbon, your nitrogen, oxygen, phosphorus, sulfur, chlorine, fluorine, all your noble gases. These are nonmetals. Anything to the left of the metalloids are known as metals. As we see here in the periodic table, we have a lot of metals that are organized. Hydrogen consists of a nonmetal, so it's just put in there as a placer, but hydrogen is actually a nonmetal. Everything here are going to be your metals. So follow this staircase. Boron is a metalloid, silicon is a metalloid, germanium, arsenic are metalloids, antimony and tellurium are metalloids. We're going to concern ourselves mostly with metals and the nonmetals and their properties. From 3b, or group 3, depending on what periodic table you have here, this big rectangle, label that with a blue stripe in one direction and the red stripe in another direction. Blue and red crisscross hashtags of this square from 3b to 2b, or all the way from group 3, group 12. These are called the transition metals. They're also metals, but they're transition metals. They're known as the D block elements because they have a D neutron shell, which we will talk about later in the course. And for now, the only thing we need to know about transition metals is that they have varying charge. So these transition metals are going to have varying charges. So you can have +2 for iron or +3 in iron. You can have copper as +2. I believe copper can also be +1. So you have varying charges. Let's talk a little bit about metals here. Now, metals are going to be hard and rigid. They're going to be conductors of electricity for the most part. So conductors. So electrons can go through them like wires. You've probably heard of copper wires. And these are generally going to be, if they're going to form an ion, if they're going to form a charge, they're going to be electron givers. So they will release electrons. They will give off an electron. So they're going to be kind of soft and brittle. Guys are going to be non-conductors of electricity. So electrons tend to not flow through them. So most of these are gases in their natural abundant state, while most metals, as you know, are solids. And these are going to be electron takers. These will grab electrons. These will give off electrons. What happens is that metals will give off electrons. And who are the takers? The nonmetals. So you see a lot of interactions, and you see the basis for a lot of compounds between metals and nonmetals. Part here, you're going to have to know what is a nonmetal and what is a metal, and you're going to have to know their charges. You have an electron giver and an electron taker. That is a positive interaction, and you have an ionic compound. So a lot of ionic compounds, such as sodium chloride or magnesium hydroxide, they involve ionic interactions, that is the giving and taking of electrons. You can also have ionic interactions with your transition metals. Besides this, metals tend to be positive in charge if they form ions, and nonmetals tend to be negative in charge if they're going to form ions. Okay, the giving and taking of electron has to do with the formation of ions. Metalloids have intermediate properties, so you'll have metalloids that can't really group these as metals, and they have properties that you can't really group as exclusively nonmetallic. So, final word here: these are the inner transition metals, the lanthanides and the actinides. Not spend a lot of time talking about them. Transition metals. And they are known as the F block elements. Just like the transition metals are the D block elements that have a D electron shell to house electrons. The inner transition elements, the lanthanides and the actinides, are known as F block elements. I just want to focus in this part of the lecture on this nonmetal portion. Now, nonmetals tend to have a negative charge, particularly 6 and 7. And nitrogen and phosphorus, they could also have negative charges, but they're not so equivocally -2 or -3. You know, nitrogen can be -3, -5. It could have different types of charges. Carbon is a nonmetal, but carbon really revolves around another branch of chemistry known as organic chemistry. So carbon chemistry is really exclusive to that branch of chemistry. So it tends not to form a negative charge. it tends to form covalent bonds, which was really the emphasis of what I want to talk about in this segment here. Nonmetals can actually interact with other nonmetals. So we can have a nonmetal react with another nonmetal. So anything in the orange here, that element can interact with anything else in the other orange shade. So is a compound known as a covalent compound. So it's important to recognize that we can have compounds formed being a combination of two elements in the periodic table, combination of multiple elements in the periodic table. Compounds can be covalent or ionic. So when you have a nonmetal interacting with a nonmetal, that's a covalent compound. A metal interacting with a nonmetal. Remember, what do metals do? Metals will give off an electron. What do nonmetals do? Nonmetals take an electron. So that is an ionic compound plus a metal. Nonmetals will take the electron, a series of electrons from the metal. This gives off the electron and becomes positively charged. This takes an electron, becomes negatively charged. You have an ionic compound. When we talk about reactions, we have a compound that's formed by just simple electron transfer, a giver and a taker. That's an ionic compound. Electron sharing. That's a covalent compound. Involves a nonmetal plus a nonmetal. So a covalent compound is different than an ionic compound. Okay, so your covalent compound is an actual chemical bond. You may have heard of single bonds, double bonds, triple bonds in chemistry. Well, that is a nonmetal reacting with another nonmetal. So, for example, CO2 is C with an oxygen forming a double bond on one end, oxygen forming a double bond on the other end. Okay, there's some electrons here as well. So this is going to be in the last part of the course where we draw structures of these. And so you notice here we have a sharing of electrons. That is a bond. So the electrons are shared. It's a covalent compound. Contrast that with an ionic compound. So magnesium itself is Mg. It can form a +2 ion. Fluorine, the halogen, by itself, can also exist as an ion, and it could take an electron, the F-. So here the +2 charge interacts with the -1 charge, and in ionic compounds we do the switcheroo, and we have magnesium fluoride. So this is an ionic compound. And this is called carbon dioxide, and that is a covalent compound. So the way you name these, nomenclature, that's lab 2. In our lab, the nomenclature of a covalent compound is going to be different than the nomenclature for an ionic compound. So just be aware, nonmetals can react with one another. Okay, that's how we get our carbon dioxide. That's how we get our nitrogen dioxide. That's how we get our phosphate in our body. That's how we get our methane gas. Okay, so that's a nonmetal interacting with a nonmetal. Metals tend not to react with other metals. So remember when I told you that group 1A elements like to be +1? So let's just pick on potassium here. Potassium by itself will be potassium without any charge, but let's say it wants to form a charge. I told you before at the very beginning of this lecture that everything in group 1 or group 1A likes to be +1. So it's plus potassium +1 as an ion. Okay, potassium as a neutral element is different than potassium ion, which is K+. Now what happens when you have something that's K+? Right? So a substance that gives off a negative charge or gives off an electron becomes positively charged. So notice the K+ is my product. The electron is ejected. Now how many electrons does potassium plus have? And how many electrons does potassium have? Right? So we're going to go into this a little bit later, but potassium by itself has 19 electrons. Potassium plus, Remember, it's given off that one electron. Now, how many electrons does this species have? 18 electrons. What other element in the periodic table has 18 electrons? It's the nearest noble gas, argon, that has 18 electrons. Chlorine is part of the halogens, which are -1. And chlorine by itself is neutral. It's a neutral element. But let's say chlorine wants to form an ion. It forms a charge. It's going to be -1. Just like everything in group 7A, or every halogen, are going to be -1. So it becomes -1. Here, in this situation, chlorine, in order for chlorine to become -1, it has actually gained an electron, and it's now Cl-. Notice here I have a minus charge in my products. I have a minus charge in my reactants. There's charge conservation. Notice here I have a 0 charge on my reactants. Potassium by itself, there's no charge. Notice here I have a 0 charge on my products because this positive charge cancels out with that negative charge. So this is charge balanced just as well as this is charge balanced. This is a metal, that's a non-metal. So here potassium has kicked off an electron to become K+, as we would expect all group 1A elements to do because they are electron donors, and group 1A likes to be +1. Here Cl has gained an electron, and we would expect that because all halogens, group 7A, are -1, so we would expect them to gain an electron. And when it gains an electron, it becomes Cl-, the chloride ion. Now, how many electrons does chlorine have? And we're going to go into this later, but chlorine actually has 17 electrons. How many electrons does Cl-, the chloride ion, have after it has gained 1 electron? It now has, this new species has 18 electrons. What other element in the periodic table has 18 electrons? It's the noble gas argon with 18 electrons. So now we have an inkling of why these like to be +1, why these like to be +2, and why these like to be -2 and these like to be -1. It has to do with the fact that they can attain noble gas configuration, or nearest noble gas configuration. By becoming an ion, this potassium now has the electron configuration of argon, and it is noble. We will talk about electron configuration later in the course. Chlorine, by taking an electron, now has 18 electrons, and it has attained the electron configuration of argon, and it has become noble. All right, so just be aware why the rationale of group 1 and group 2 and group 6 and group 7 to have those charges, +1, +2, -2, and -1. Now, we can't go and say that for these other elements because these other elements have different charges and they have different requirements. We can only say this unequivocally and unabashedly for group 1, group 2, group 6, and group 7 because these have the closest ability and the strongest probability of attaining nearest noble gas configuration. Let's do one more of these. Okay, let's pick on oxygen. Okay, if oxygen gains 2 electrons, because oxygen and all these elements in this group like to be -2, so oxygen by itself is fine. It gains 2 electrons, it becomes O-2. Okay, so this oxygen actually has 8 electrons. We will talk about that in our next section. It's gained 2 electrons, so how many electrons does O-2 have? This O-2 species, this oxide anion, has 10 electrons. What other element in the periodic table has 10 electrons? Well, it's its nearest noble gas, neon. So now by gaining 2 electrons, this O-2 has the electron configuration of neon and is content. It's become noble. Neon by itself is a neutral element. If it forms an ion, it would want to form a +2 ion and give off 2 electrons. Calcium by itself has 20 electrons. It loses 2 electrons. How many electrons does calcium +2, its ion, have? Electrons, it's lost 2 electrons. What element in the periodic table also has 18 electrons? It's going to be calcium's nearest noble gas, and that's argon. So by calcium giving off 2 electrons, it attains the noble status, the noble electron configuration of argon. If sodium gives off its electrons, sodium has 11 electrons. It gives off 1 electron and it becomes 10 electrons. What does it become in terms of its nearest noble gas? It becomes neon. Okay? If lithium gives off its 1 electron and now has 2 electrons instead of 3, neutral lithium has 3, lithium plus has 2. So what is its nearest noble gas configuration? Helium. Don't get confused. This is a sticking point for confusion. If potassium wants to become the electron configuration of its nearest noble gas, okay, its nearest noble gas is argon. Lithium, its nearest noble gas is helium. Okay? Cesium, its nearest noble gas is not this guy, but it's xenon. Okay? Same thing here. Selenium, if it wants to obtain its nearest noble gas, what is it? It's actually krypton. If oxygen wants to obtain its nearest noble gas, what will it be? It will gain 2 electrons and become neon. If iodine wants to attain its nearest noble gas electron configuration, it gains 1 electron and it becomes xenon. Okay? So just be aware of this concept of nearest noble gas, and that will help you realize why some of these groups like to be +1, +2, -2, and -1. So these are special groups. In fact, these would like to form ionic compounds, as we will see later on in the course. Okay, this is not so definite, okay, these guys. But group 1, group 2, group 6, group 7 are definite ionic compound formers because they can easily attain nobility. They can easily attain the electron configuration of its nearest noble gas. Let's take a look at one box inside the periodic table. I'll just pick on manganese. And we'll ask ourselves the question, what do these numbers mean? All right. The most important thing here is this big number, 25. Whether it's going to be 25 for manganese or 26 for iron or 24 for chromium or 19 for potassium. Okay, that 25 is the number of protons. It is known as the atomic number, abbreviation of Z. And this is invariant. The atomic number really defines that element. The atomic number Z, which is the number of protons in that element, is absolutely invariant. What do I mean by invariant? It does not change. It simply does not change. Okay? So 25 is the number of protons in manganese. It's invariant. Why can I not change the number of 25 to 26? Because if I change from 25, the atomic number Z, to 26, I don't have manganese anymore. I have iron. So that 25 is the number of protons in manganese. That number 26 is the number of protons in iron. That number 19 is the number of protons in potassium. It cannot change to 20 because I won't have potassium anymore. I'll have calcium. So the number of protons is invariant, does not change. Atomic number Z, the number of protons does not change. Now let's look at this number. This 54.938 is called the mass number. It is the number of protons and neutrons. Protons plus number of neutrons. That's one definition of that number. Is the atomic mass unit. Atomic mass unit. Okay, if I could spell. Atomic mass unit. It's our AMU. And very, very important, it's the molecular weight in grams per mole. Grams per mole. Or G per mole. Well, let's go back to manganese here. That 54.938 has three definitions. That 54.938 for manganese, whose symbol is Mn, could mean in definition 1, there's 54.938 protons plus neutrons. If you're wondering, where does the 0.938 come from? Why do I have a decimal? Okay, that's because we have isotopes. And what you see here is an average atomic mass, an average weighted mass number, because manganese has different types of isotopes. The manganese you see here is manganese that contains different number of neutrons that contribute towards its natural abundance. Definition is this is 54.938 AMU, atomic mass units, and the third definition is that it's 54.938 grams per mole. The molecular weight of 1 mole of manganese is 54.938. Similarly, 1 mole of iron can be 55.845 grams. This can be 55.845 atomic mass units, or AMUs. And the mass number of iron is 55.845 when you sum up the protons and you sum up the neutrons. Now, why is this not a nice round 56? And why is this not a nice round 55? Because there are elements of iron that have a different number of neutrons. We have isotopes. Those isotopes, no matter how small they exist in nature, contribute towards this average atomic mass, or the average mass number, or the average molecular weight in grams per mole. All right, so here is your element. Here's the element name, the atomic number, the three definitions of this number, the molecular weight in grams per mole, the atomic mass unit, and the mass number of protons plus the number of neutrons. Now, what about ions here? So manganese by itself is going to have 25 protons no matter what. But how many electrons will it have? It's going to still have 25 electrons. You don't see any plus charge here. You don't see any minus charge here. Obviously, it's a metal, so it's not going to have a minus charge. But you don't see a charge here. You don't see a charge, so the number of protons equals the number of neutrons. Okay, iron. How many protons are in iron? 26. That's its atomic number. How many electrons are in iron? It's 26. You do not see a plus charge anywhere here, plus 2, plus 3, or anything. All right. What is the number of protons it contains? 19. How many electrons does it have? 19. Okay. Now, I'm going to change the game and tell you, or ask you, potassium ion, K+. How many protons does it have? 19, because it can't have 20 protons, that's calcium. It can't have 11 protons, it's the sodium. It's still going to be 19 protons. The minute I added that ion and gave it that plus charge status, I have messed up the number of electrons, and this is a critical point. So how many electrons does potassium ion have? Okay, the answer is 18 electrons. 3. Okay, phosphorus by itself is going to have 15 protons. P minus 3 is going to have 15 protons. How many electrons will P minus 3 have? The answer is 18 electrons. Take a look at a couple of problems here that involve determining how many protons, neutrons, and electrons are in a given element. So this number 37 actually refers to the mass number, which is the number of protons and the number of neutrons in that element. So that subscript to the left of the element is the mass number, which we now know is protons plus neutrons. What does that minus sign indicate? That minus sign indicates that this chlorine has become an ion and become the chloride ion, and it has gained an electron. So, first of all, what are the number of protons in chlorine? This is the easiest thing you can actually answer, because all you got to do is look it up in the periodic table, and you'll see that that big number for chlorine is going to be 17, and that's the number of protons. So the number of protons is 17. What's the number of electrons? All right, it has gained an electron, hence that minus sign. So now you have 18 electrons. So the number of electrons is 18 by virtue of that negative sign. Okay, number of protons and neutrons is the mass number. The mass number is going to be 37. It's always written to the left and a superscript to the element. So the mass number is 37. The number of neutrons is going to be this plus this is going to equal that. So this plus 20 has a sum of 37. Remember, mass numbers, protons plus neutrons. What about this one here? Okay. The number of protons is 11 for this element. There we go, sodium. Now for the exam, you're going to want to write sodium, but you also want to include the mass number and any ions that may be involved. So sodium has 11 protons, 12 neutrons, so the mass number is 23. Look at the number of electrons here. Okay, so you have protons at 11, electrons at 10. Did sodium give off an electron? Yes, it did. In order for sodium to have 10 electrons, it had to give off an electron. So it's sodium plus, and the mass number of sodium is 23. So this is how you want to write the answer on any test or quiz. All right, be aware that this is the sodium ion. Okay, sodium by itself will have 11 protons and 11 electrons. Sodium ion would have 11 protons and 10 electrons. Electrons for this species is 36. The number of neutrons is 46. The mass number is 81. We know that the number of protons plus neutrons is equal to the mass number. So to get the number of protons, which tells me my element, I have to do 81 minus 46. So 35 protons. I have 36 electrons. So did this element gain or lose an electron? Okay, it's gained 1 electron. So that means it's a minus charge, a minus ion. So what atomic number 35 designates that element? So the answer for this one is Br. The mass number is 81, and the charge of that is it's not neutral. It's gained an electron to go from 35 to 36. Number of protons is 88, Ra. This mass number is 226. It has 86 electrons in an element that is 88 protons, so this has lost 2 electrons. When you lose 2 electrons, you lose 2 minus charges, and when you lose 2 minus charges, you become positive 2 charges, so positive 2. The number of neutrons is going to be 226 minus 88, 238. All right, barium plus 2 has a mass number of 137. The number of protons in barium, 56. Number of neutrons is going to be 137 minus 56. So whatever that math turns out to be, 81 neutrons and plus 2. Which means that this has lost 2 electrons in order for barium to have the plus 2 status. So we have 54 electrons. How about this one? Number of protons is 30. Anytime you have number of protons of being 30, that's a dead ringer to just automatically go to your periodic table. 30 protons is zinc. The mass number of zinc is 30 plus 34 is 64, so I put my 64 here. And it has 30 protons, the number of electrons is 28, so this has lost 2 protons plus 2. The number of protons in this element is not given to us, but the neutrons is and the electrons are. The mass number is 32, so the protons plus neutrons must equal 32. So only 16 plus 16 is 32, so 16 protons. 16 protons is sulfur has a mass number of 32, and the ionic charge 16 protons, 18 electrons. It has gained 2 electrons. Number of protons in this problem is 40. 40 is going to be zirconium. Zirconium. We have a mass number of 90, and which means the number of neutrons is going to be 50, because 40 plus 50 is equal to 90. And 40 protons, 36 electrons. This zirconium has lost 4 electrons to become plus 4, and its mass number is 90. So for 23 sodium, you have 11 protons. Just look it up in the periodic table. You'll have 23 electrons because there's no charge here. You don't see a plus charge anywhere, so it's 23 electrons. The mass number is going to be the protons plus the number of neutrons. So 23 minus 11 is going to be 12. And I got the mass number from over here. Substance or an element in the periodic table that has 39 protons. Let's check that out. It's this element here, yttrium. So that is Y. 50 neutrons plus 39 protons gives you 89 as the mass number. And the number of electrons is still going to be 39 because there is no charge associated with this species. If the number of electrons are 50 and this is a neutral species, then the number of protons will also be 50. And an element with 50 protons is tin, whose abbreviation is SN. And 118, the number of neutrons here is going to be 118 minus 50, and that's going to be 68. So you can see that if you don't have ions, your work is substantially more easier for neutral species. 79 protons, looking that up in the periodic table, is going to be gold. That's your atomic number of protons. The mass number always goes to the left and up. So gold 197. If it's a neutral species, the number of protons equals the number of electrons, and the mass number is 197 minus 79. All right, a final problem here. These are all neutral species, so we should be able to flow through these really quickly. The number of protons in Al, you don't see a charge here. The mass number is going to be 27. The number of protons is going to be 13. The number of neutrons is going to be 14, and the number of electrons is going to be 13. This is the mass number. Okay, so protons plus neutrons. That's the designation. Right, a substance with 42 protons. If we look that up in our periodic table, you'll find that it is molybdenum. Protons plus neutrons is the mass number, so that's 96. And because these are all neutral species, this will have 42 electrons. Protons and neutrons are the same in a neutral species. What about this? The number of electrons are 60. If we know that this is a neutral species that does not form ions, it's going to be 60 protons. And this plus this is your mass number, so that will be 83 neutrons. And an element in the periodic table that has 60 protons is going to be this element here, neodymium. Neodymium. So Nd 143. And finally, number of protons is 92. Number of protons in the element with 92 protons is uranium. And the number of electrons, if this is neutral, it's going to still be 92 if there's no charges. The number of proton is equal to the number of electrons. The number of neutrons is going to be 238 minus 92, so 6.